again. Um, Today, I hope you saw the data modeling lesson, and that should help you, right? Now, what has happened is before the data modeling, I actually created a domain modeling lesson, but it sounds like the video was not of good quality, and I ended up deleting that video, right? So, the data modeling lesson is good enough for you to get an understanding of what data modeling means. But then the domain modeling lesson, now that I deleted the previous video, I want to take a little bit more systematic approach and kind of give you a lot more context, because the domain modeling video I did is so that it will be an introduction to the data modeling lesson. Okay. But after doing the data modeling lesson, I realized that, well, maybe I don't have to give that context. You will already understand it. But domain modeling is equally important because in today modern application development, um, we deal with what we call as microservices. So there is a movement that's going on in the software development world where we want to build our software to be more reactive, and also we have this concept of a microservice, right? And um, when you're building this microservice, 10 or 20 years back, we had this idea of building our software based on the jargon that is used in the business, right? To kind of get a business domain understanding and then model our software based on that business domain understanding. And that is common sense because that's what we do. But um, we have this design approach called domain driven design. Okay. We call it, in short, we call it as DDD, D cube, or something like that. So, what is domain driven design is really trying to understand the business domain and building your software based on that. Okay. So, I'm going to explain to you that part and then get into some sort of domain model. And then hopefully this time the video is going to look good so that it actually imparts you the right knowledge, right? So I'm going back to this Lucidchart. I'm going to create another blank document and domain driven design, right? And I think we can get into, like I can close that. Oh, let me see. Yeah, this is good. Okay, so when we talk about domain driven design, um, there is a concept of a thing called bounded context, right? And we'll start with bounded context first. So you take some e-commerce website, just the commerce part of Amazon.com, right? Not the other side. There is so many different domains that is involved, right? So um, really speaking, that if I start looking at, so let's say, let me see what how I can describe the bounded context. Um, I'm thinking that I will look for a UML. So instead of flowchart and geometric shapes, let me go take UML. Okay, so maybe UML. And I don't want any of these other diagrams. I do need the use case diagram. Okay, in fact, they have UML. They have a entity relationship diagram, I think. So I probably use that. Yeah, they have that. That's nice. Okay. Now, the entity, we talked about entity in the database model context, right? And you've seen that video. So the entity there is nothing but a table, and we were thinking about, hey, there should be some identification of this table, things like that, right? Now, in the domain-driven design, there's still something called as entity, okay? But it's different. So I'm going to explain to you the difference. But before even we go there, there is something called as a bounded context, right? So what is a bounded context? The symbol to actually talk about bounded context, right? Let me tell you what bounded context is. So a bounded context is that from business point of view, it's an independent functional unit that can do one thing for you, right? For example, in the Amazon case, if you're talking about shipping, okay, now think about all the things that shipping needs to do, right? Um, it somehow needs to, the shipping department somehow needs to get an order, and from the order, they know what's the delivery address. And once they know the delivery address, they need to plan to ship a product. But they cannot ship a product until the product is packaged and ready, right? So let's say that the product comes, so they get an order, so they get some heads up on, hey, there's something which is going to be shipped soon, right, to this address. And they already know what product is going to be shipped, what's the product weight, everything, okay? But then now the shipping department has to plan the logistics of, okay, so which route am I going to take? What all means the transportation means I'm going to take? Is it a plane? Is it going to be a ship? Is it going to be ground? And from point A to point B, if I use all of these transportation methods, how long it's going to take? What's the estimate? What's the estimated time of arrival for this shipping route that I've taken? So all of these things will have to be planned. The shipping route has to be planned and everything. And in between, you are making some notifications. You're sending notifications to different departments, right? You're telling to the transportation system that, hey, I want to take this much load into your plane, into your truck, into your ship, whatever. So you got to give them a heads up of what's going to happen. And then you also are notifying your customer that, hey, it's going to take this long for you to receive your package, okay? Then the packet really arrives. So now you are printing a shipping label, stamping it on the package. The shipping label is going through various units, and everywhere the shipping label is scanned, there is a notification sent to everybody saying that, hey, this is where this particular shipment is there. And then finally it reaches the client, right? So all of that belongs to one functional unit, and their focus is shipping. Whereas if you take another department like payments, their focus is really different. Their focus is really payments, right? So their focus will be all the different types of payments that they can receive. How does the chargeback occur? What happens if the customer doesn't like the product and they return it? How do I charge back? The security that surrounds payment systems, what needs to be reported, what should not be reported, how do we store the information, the payment information in a secure fashion. Those are the concerns of the payments department, right? And then the in our case, the sales department, is their concern is about, hey, am I keeping, am I displaying the right products for the right customer? Am I answering all the sales questions that the customer is having? What about closing the sales? What documents are necessary for closing the sales? They are concerned about that, right? So, but when we are building software, the idea is that these bounded context needs to be set in its own boundary. What do you mean by that? It's like we used to build systems where, hey, I build a database. I put all the shipping tables in it, all the payment tables in it, all the sales table in it in one database, right? And then I put that all of that there, and everybody is hitting the database to do something or the other to do with the database, right? Okay, that's fine. Now you want to scale it. How will you scale it? You'll have to take the whole database and replicate. Once you replicate it, you got to think about how you're going to sync the data between these different departments. You see, things become really, really hard when you want to scale. And then on the top of it, the sales side may have to use the database a lot, whereas the shipping side will use it like if there are 10 different sales calls that is being made or 100 different sales calls that is being made, only one sale gets closed. And therefore, the shipping is 100 times less, the shipping takes 100 times less load than sales. Same thing with payments. So you cannot scale these systems independently because the common denominator for all these systems is a database. Okay, but if you have these bounded context, of course they have dependencies, right? Obviously, sales as at some point sales is dependent with, let me see, uh, sales is dependent on shipping, right? And it's dependent on payment, right? So there are arrows going, but those arrows will have to be loosely coupled. That's the idea, right? Those arrows need to be loosely coupled. What do you mean by that? So I do need to have a sales database. I do need to optimize my sales for sales requirement, the bounded context. I didn't need to scale it. I didn't need to have a IT department taking care of optimizing sales. But I should not be caring about shipping and payment. What I should be caring about is once the sales is closed, I send a event, a notification to shipping. And maybe I'll send another notification to payment. And those departments will have to scale their system and build their system and whatever the caching and everything else that's required for that system in that department. So they will have an independent database. I will have an independent database. Shipping will have an independent database. These databases are no way connected. The only connections these systems have is that they get a message or an event when something happens. So now what you've done is you have loosely coupled sales, shipping, and payment. They all can scale independently. They all can have their own infrastructure independently. And they all have contracts. What is the contract? They will receive an event with some data in it. So as long as these units agree on what the data is, then that's all they need to know. They don't need to know anything about sales at all. All they need to know is, okay, the sale is closed, these are the products that's been bought, and this is the total cost which the customer needs to pay. And the customer is using a particular payment method to pay for it. That's all they need to know. Whereas the shipping department doesn't even know whether things are paid or not. For them, as long as the sales says that, hey, ship this, they'll have to find out, okay, what is the delivery address, what is the weight, and how fast this needs to be shipped. That's all they need to know. They don't need to know anything more. So that is called as a bounded context. And here, it's so easy to find bounded context because we are familiar with the business domain. But in a complex scenario, the bounded context is very, very difficult to understand, or for it's very, very hard to figure out these bounded contexts, right? I'll tell you so I'm going to take this domain off because this domain is easy and we already did a data model on it. So I'm just thinking that it's a very, very easy domain, right? But we'll talk about the domain that I'm working right now is the document management domain, right? In a financial company. And I think we already did the process model for it, if you remember that. So here, what is happening is, I'll give you a very interesting problem. So there are some domains that's very easy to understand, but there are other domains that's hard to understand. Okay, so I will give you this. Okay, so I have, let's say that there is a um, domain called generation. Okay, this is document generation. Okay, so I have a document generation domain, and I know that this is basically, I have a template and I have incoming business data, and I got to generate the document. And my concern is only generating the document. There is another business unit called delivery, and their concern should be only delivery, right? Okay, so I have a document to generate and a document to deliver. Okay, now if you think about it, when I'm generating the document, I do need to know, even though we say that, hey, you don't need any knowledge, I do need to know where it's getting delivered, or whether it's getting delivered at all, right? Why? Because that when I am generating a document, if it's sent as an email, I need to generate HTML. But if it is sent for as a fax document, then it depends on what type of fax system I have. It could be a TIFF, it could be a PDF. So I do need to know the delivery format for generating the document, correct? So that's one issue. The other issue is that I probably need to ask the delivery system that, hey, the document that I generated, is it good enough for delivery? So let's say that I create a TIFF document with certain color profile, and I send it to the delivery system. The delivery system says that, hey, our fax system doesn't even support this color profile. So you will be getting dark black pages if you send something in this color profile. And this really happened. So that's why I'm telling you. So there is a concern where that, yeah, I can send you an event, but you probably are going to send an event back to me saying that, hey, your document is not formatted right. Okay. Now, even further, we have a process to capture incoming letters and communication, right? It's called as a capture domain. Okay. So what happens in large financial companies is that customers also correspond with you. They send you they fill up a form and send you some signed document, right? They send you payments. They may even send a complaint. Okay. So when that happens, that in a very large company, you're not going to have one person opening the letter and reading the whole thing and then recording it in a file. That's not how it works, right? The way it works is the letter comes, the letter gets dumped in one spot. There are machines to actually take the letter out and make sure that there's nothing mischievous about it. Remember that we had this situation where they're sending us letters with some bio hazard or bio weapon with it, right? So we scan for all those safety things. Then there is a machine that cuts the envelope out, scans the from address and to address and captures that in a scanner, then removes the letter out, actually throws the letter into a scanner and try to read try to take that scanned image. Sometimes they also use OCR to pull the content and throw it in various databases, various systems, and store it there. Okay, and they do this all in an automated fashion. Okay, and so capture, when it captures these documents, there is another domain called storage. So they constantly capture and they pull and they validate incoming document, and then they figure out, okay, where this needs to go. I mean, even checks are scanned, and we don't need, I mean, the checks need to be electronically processed. If you take a company, we don't take a check and go to the bank and process that, right? We just scan the check, get the details in the check, throw that to the payment department, and the payment department says, oh, okay, here is the routing number, here is the account number of the check, and here's the check number. Then we send the communication through ACH, which is called as Automated Clearing House, where there is a central gateway where we say that, hey, here's the check, here's the thing, we need the money, and that gateway takes the communication to that specific bank, and the bank says, okay, I think this check is authenticated, and then the check, the account does have the money necessary, and so they just send a notification, okay, we will pay you, and then the money gets transferred to our bank. It's as simple as that. But we got to store these checks for evidence. Okay. So what I'm trying to say is the capture system has relationship with storage, right? Now what happens is at some point in time, sometimes we need to send a communication to our clients, but while sending the communication, think about the communication that we sent saying that, hey, here are all the checks that you wrote um, to us, right? Or here are all the checks that you wrote to, here are checks that you wrote from our bank, right? So in that case, what happens is document generation actually pulls data from storage, which is already stored, and then combines the data with whatever data it generates, and then sends it to delivery, right? Okay. And I'm talking about all these things because I'm a domain expert on these. Okay. For a new software engineer, these things they will not even be aware of. They don't know what is captured, they don't know what is storage, they don't know how all these things happen, right? So the idea for a software engineer to actually build a system, to build a software, to manage all these things, is to understand the business domain and also understand the domain, the bounded context, right? If they know the bounded context, then they can think about, okay, I will build my infrastructure, software infrastructure that includes database and network and queues, cloud infrastructure, all of those things around that bounded context. And then I will also think about how these bounded contexts react to each other's events, right? What are those events, and how should I react to them? If we build systems that way, then we are building loosely coupled systems that can be maintained even better, right? So that's where we start with when we do domain modeling, is that we look at each of these functional units, okay? And it can come very easily from your process diagram also, right? From your BPMN process picture, you can easily get, okay, this is the process. So it sounds like all these things belong to one system and all these things belong to another system. So I went a step backward and I kind of explained to you how to define these bounded contexts. Now, once you define these bounded contexts, then we think about something called as building analysis classes. Okay. So in order for me to explain what is an analysis class, I will have to get a better picture for you on what is a class itself, right? What is a class? Okay. And in order for us to clearly understand what is a class, we kind of need to understand some of the real world things, okay? So think about a real world thing like a driver's license, okay? So if I ask you, why does a driver's license exist, right? We can easily say that, hey, a driver's license exists because we identify a driver and we know that the driver is competent enough to drive a certain type of vehicle, and their health condition and their eyesight is all verified so that they have the permit to drive in a road with with very less chance of coming up with an accident. Okay, it's a government concern, it's a public concern, but a driver's license exists because of that. Okay, now if you take a driver's license and if you look at your own driver's license, you can see that there is a driver's license number, there is a when it got approved date, then it has a expiry date. It tells you um, what class of vehicles can that driver drive. There is a driver's picture, there's a driver's date of birth. um, so it also acts as an identifier of that person, right? And it can also put certain things about the driver, right? Maybe the driver had some it's a provisional license because they had some accident or something. They got a ticket. There's some driver's license even have points with it. So all of these things are included in a driver's license. And if you see that your driver's license also has a magnetic strip behind your driver's license that has all this information and maybe a little bit more information that will be used to identify you as a driver. Okay, so what I mean by that is that a thing called driver's license contains some data. Okay, it represents some data. It also represents all the operations that you can do on that data. So for example, you take this driver's license, after 10 years you need to renew it, you are going there, and then at that point in time you are wearing a glass and you still have to check your eyes, and then they will tell you that, oh, okay, after wearing the glass it looks like you still have good eyesight according to the standards that we have set. So what is happening is that somebody will have to change the data about your eyesight, okay? Or somebody needs to change your data about your age. So when changing the age in the driver's license or changing the eyesight configuration in the driver's license, or sometimes I got disabled a little bit, so now the original driver's license is to drive a regular car. Now I should have the driver's license to operate a car with equipment for my disability. So things might change. But who can change all those things? We really see that there is a driver's license record, and there has to be a person who's authorized to change that record, will take a look at it and they will change it. But are they changing it like taking your record and striking it out and writing it? Well, that would have happened 100 years back. But today, what's going to happen is the software that's going to pull your driver's license record, and it's going to go and change that data. Okay. So what does all this mean? It means that in the real world, when you take any object, the object contains state or data. That is the state of the object, right? It has height and width and size and names and everything associated. So there is data associated with an object. And there are ways in which you can change the state of the object, but you cannot directly go and change them. You're actually, doing something to the object to change it. Okay? So this class of objects that are similar kind of data and similar kind of operation is really called a class. You understand? So these are real world objects. These are mimicking or representing real world objects and real world operations, but inside your software. That's what is a class. Okay? So previously, when we were originally building stuff, we were always thinking about data, okay? And we were thinking about the operations on the data. But we kept them separate. We said that, hey, here's a bunch of data, here's a bunch of operations. And the problem with that approach is that there are a lot of operations that can go and touch the data. So operation A, which is aiming to test the data in a certain way, and operation B, which is aiming to test the data in a certain other way, can have a conflicting interest on the data, and the data gets corrupted. Sometimes accidentally, sometimes as a bug, but the data always gets corrupted. So like how we build database systems that has data integrity, and we had the first normal, second normal, third normal forms, so that the duplicates are eliminated. There is no chance that there will be wrong data that will be entered in. We applied certain rules. Same way, we thought that in the software business, let's organize data and operations together and make the data private and operations public, so that if some other system want to affect the data, they can only go through these operations which will have valid reasons to update the data. So the knowledge of how to deal with the data which is inside that class is known to only that class. For the outsiders, it's just an interface. It's like pushing a button. It's like moving a lever. It's like using the steering, right? When I use the steering or move the button or press the brake in the car, I know what will happen to the car, but I don't need to know how it internally works. So what's the advantage of that building such system is that if I have that, then as technology improves, the way I handle the braking, the way I handle the steering, the way I handle the the ignition, all that can change over time. But as far as I'm concerned, I'm still steering, I'm still braking, right? Think about electric cars versus regular cars. The interface is the same. I still need to drive, I still need to press the brake, but internally they're using completely different mechanisms to do the same work. So all of these things can possible. You can upgrade your systems much more easily as long as you don't change the interface. So that's why object-oriented systems came into place in the first place, right? And so when we, as like reactive systems, as like microservices, we can think of these systems at a very high level, and we can also think about it as programming elements, right? Sometimes, so you can build reactive systems without reactive programming, okay? Same way, you can build object-oriented systems without object-oriented programming, okay? And we are doing that today, right? Right now, we are doing. So, for example, when you say that, hey, we are building microservices, REST-based microservices, right? I can use a procedural language many times to build my REST, to back my REST service. But the REST service is still object-oriented. Why? Because it exposes certain operations and certain amount of data, but it doesn't expose the internals of the data. So from a client's perspective, they're still talking to an object. But internally, you may deal with it in whichever way you want. So now coming down to analysis classes. So an analysis class is very similar. It's a conceptual thing. You map to whatever technology you want to map to. But conceptually, it's a class which has data and behavior. Understood so far? Okay. Now, how do I represent that? Okay. And so what has happened is when you are doing domain-driven design, if you take a class, and I'll take a class here, I'm going to take a simple class, right? So there are classes, that the classes themselves, and again, these are analysis classes, not programming classes. You can build programming classes based on this, but these are analysis classes, right? We say that, hey, there are by nature some classes, those are those have an identity with it. See, for example, yesterday when we looked at customer, the table for customer and the table for product, we clearly know that there is a product number, or we clearly know that there is an order number. We clearly know that the customer has a name, right? So there are some identity to it. But think about the address object. It doesn't have any identity. We made up some identity. We said location code, latitude, and longitude. But really speaking, you cannot identify that object on its own. And then the other idea is that the moment I delete a customer, the moment I delete a shipping, the address doesn't have any meaning. Address doesn't exist on its own, unless otherwise you're building a mapping system. Okay, so that means that there are some data oriented classes in my system, or data oriented objects in my system, like a driver's license, right? So we call all of these classes as um, domain classes. Okay, we call them domain classes, but these domain classes, or they themselves divide into three types. Okay, I don't know why I selected an interface. Come to the class, right? So there are some classes which are called as entity classes. Okay, and that's because they all have identifying data. They are identifying data. They are the primary data, right? Like your customer. Customer is an entity class because it has a customer ID, a customer name, etc., etc. Okay, it can identify, and it will end up in a database as a table. Okay. Then there are classes which are, we call them as value objects. So these value objects cannot live on their own, but they actually belong to entities, right? And I got to change the symbol here, and that's where we use this diamond symbol. Okay, I'll have to change that again because I don't want diamond that way. Let me see. So I'll put a none this side, and this side I'm going to put a diamond. Okay. What it means is that a value object cannot live on its own, like something like a customer's address, right? It's a value object. It is identified by that customer. Okay. It's the customer's address. But even though it's a customer's address, hold on, trying to do something here, it's not working. I'm trying to make it bigger. Okay. And by the way, when I'm using these double angle brackets, those are stereotypes in UML. Stereotypes means a particular type of class. Okay, these are all stereotypes. So an entity can be a customer. The customer stereotype is entity. Okay, so I'm just putting the stereotypes in here. So generally speaking, value objects exist because entity exists. When I delete the entity object, the value objects will also get deleted, and therefore they are called value objects. Then there's one more domain class called as an aggregator. I'm going to put a class here, and I don't know why this class looks different. Let me see. Hold on. Deleting it. Okay, this class. Okay. So this class is called as an aggregator. aggregator. Okay, so, or an aggregate. Okay, what is an aggregate? An aggregate is a class that through which you can talk to a different class. So, in other words, that I know that there is a customer, and the customer has a bunch of value objects, which is addresses, right? But think about a bank account. Okay, so if you take a bank account, the bank account can have multiple account holders. So each of those account holders are themselves entities, but when you talk to that entity, that account holder, you do it through a bank account. Okay, so that means that there is a class that aggregates the behavior of other classes, other entity classes. So that's why they're called as an aggregator. And so when you put these aggregators, then I can draw a line this way, and this is the way you model this in a UML diagram. Is on the other side you're going to have a diamond, but it's not a filled up diamond, it's an empty diamond. Okay, that shows an aggregate relationship. Okay, and I also made a mistake. The diamond has to come this side, and I am going to put a none here. Okay, so that's what these aggregators are. So all of these three types or stereotypes of classes: entities, value objects, and aggregators, they are domain objects. Okay, they are objects that will probably end up, the data for those objects will end up in a database, right? And then the objects themselves, they will exist in the business domain, no matter whether you're implementing it in C++ or you're implementing in Python or you're implementing in some other mainframe, PL1 language, right? Those objects exist because the business exists. That's it. Okay. So if you can put the domain model for those and document it somewhere in terms of pictures, you can implement it in any technology you want, but it's going to remain the same. And when you build that core set of objects this way, having a very good understanding of business, here's the advantage. And what is the advantage? Now, around this system, you can build what is called as boundary classes. Okay, what are the boundary classes? So there is a stereotype of classes called factories. Okay, and what is a factory? So a factory is somebody or some sort of class that has the ability to produce and destroy these objects, because producing and destroying these objects has some business rules associated with it, right? But they are basically, they kind of use these objects and produce them for various reasons. Okay, I want to produce these objects for it to exist in the user interface, or I need to produce these objects so that they need to be filled up, and then later they need to be persisted, right? So they're called as factories. That is, factories produce these objects to live in memory. I'll put it that way. Okay, factories produce these objects to live in memory. So you don't directly create these objects, but you use factories to create those objects. Why is that? Why do we need that? So that means it will shield. So you're creating these pure objects. The way you're creating it, that logic will be shielded from corrupting the domain. And the domain should never change. Factories might change. The way you create these objects might change, but the domain should never change. There is another set of objects very similar to factories. It's called as repositories. If factories create and destroy objects, repositories loads and unloads them. Okay, so basically all your database operations of these objects will have to handle the actual database operation themselves, not the business logic. Remember, just for us to load these objects with whatever queries you can load them, and to unload them and to modify them, all the database operation behind the scenes, that will happen through repositories. Okay, then there's one more type of object called a utility or utilities, right? um, we call them actually service objects. I want to make sure. Okay, a service object is actually it this is the one that actually does a service. For example, you have an entity and you need to send an email, then you use a service object, right? You want to take this object and throw that across a HTTP network for it to fulfill a REST request. That is a service object, right? Which is actually basically a utility. Okay. Some in some books they also put utility as a separate thing, but I think keeping them as service is good enough. So these are the 6 types of domain objects that you have in a domain model. Okay, and in fact, when you build the domain model, you don't even care about these things, because these things will keep changing over time. As technology changes, these things will be changing. For example, for repositories, we used to have some JDBC related classes in Java, right? They then changed into Hibernate. Then they bought in JPA. So the way you are loading and unloading the data is changing over time. As far as factories are concerned, we used to have objects called factories. Then we had something where you can actually look up an object using some technology called JNDI in Java. Um, then after that, we got Spring, which is a framework for something called as inversion of control, which again is how do you create objects with certain context data. So those are all factories. And then obviously we have services that could be in the model view controller pattern for UIs. It's actually the controller, right? That could be REST services, SOAP services, all kinds of services that that takes these domain objects and invokes their behavior, changes their state, and then does something with them collectively, right, to fulfill a particular situation, right? So, for example, I want to add something to the cart. Okay, so the service object does that. Then I want to take everything that is in the cart and pay for it. Service object that does that, right? So the service object is the one that is involved with event generation, listening to events, responding to users' requests. So that's what the service objects are doing. So in theory, and this again is theory, if you have a very strong domain model and real technology that backs this domain model, keeps them in, it has the way to keep them in software, then in theory, as things change, as the world changes, as the technology changes, you only change these factories, repositories, and services. The domain object doesn't have to be touched at all, because the rules of creating this data, changing the data, doing things with the data resides in the domain object, right? And then there's another concept today which is called as so those domain objects have to be rich. What do you mean by that? So it's not just data, but all the rules of changing the data, all the business rules of um, um, changing and adding and removing the data also should reside in the domain object, should not be outside, right? So therefore, if you have, like for example, if you have payment system and somebody is telling you that hey, pay through this particular um, method, and they don't send you some specific data like the CVV number, then it is that object that needs to say that, hey, you got to send me CVV number. So the validation rule for CVV number has to be in there. The validation rule that your credit card number has to be 16 digits and it should start with certain numbers for certain type of credit cards has to be inside the entity object, right? It can't reside in the database, but it can still reside in the object that you're creating in the software. So why is because that once those rules are all set in, that's not going to change. In 50 years of business, payment is never going to change. Now, obviously, today we are going to pay using a mobile phone. Tomorrow we may pay through a Google Glass, right? That interface is going to change, but the domain model is never going to change. Okay, and that's why this layer of domain model should be preserved. And that is really why we need to do business domain modeling. And in my experience, once you have the business domain modeling, the creation of the data model becomes very, very easy. Okay. And so for this is all for you to grow up in leadership to become, you know, architect maybe, lead software engineer, lead staff engineer, principal software engineer. So when you're going through your career, initially you'll be thinking about algorithms and building them and representing them in the form of software, right? And this applies to data analysts and all the IT analyst people. Initially, it's all about the small details, but later, as you grow higher and higher, you got to think about how do I design a system, right? How do I design the data model? How do I design a software model? How do I design my UI? But here, as you see, slowly over time, I realized, like when I was very, very junior, I used to think about, hey, how do I build a wireframe for my UI? And later I'll think about what I need to fill it up in the backend. Guess what? After I build it in 3 months, that code is unmaintainable. The UI looks very great. Have you seen? So there's a lot of nowadays. There's a lot of web application. The UI looks so great. You enter the information, and suddenly there's all kinds of bugs that's coming up. Okay, recently I saw. And this UI is maintained by Department of Education. It's called as FASFA, where I want to fill in some information for my son's college. The UI looks fantastic. Okay, I enter something in the UI, it just comes back with error messages that I don't understand why it is there, and I need to do all kind of hacking for it to work. Why? Because somebody built the wireframes, spent a lot of time building the wireframe, but did not do the domain modeling to build the application, did not think about bounded context. So things are not scaling and systems are not talking to each other the way they are supposed to talk. And also my data model doesn't have any data integrity. Okay. And all kinds of errors are thrown. Nobody knows how to fix that. That used to be before. But nowadays, I really think about, okay, I need to understand, I need to go to the end user business SME and talk to them and find out how does their business work. And then I need to come up with the domain model and back it up with the right data model. And if I do those two things correct, then it's the question of building the factories and repositories and services to service a UI. And in fact, I should build all these things independently before even I come to a point where, okay, now I put a wireframe. And after I put the wireframe, all I need to know is which service to call for what effect in the UI. And that's pretty much it. Now, don't get me wrong. UI is a very important concern because in terms of UI, what you're going to think about the human interface, the ergonomics, usability, ease of use. Those are very important topics, no doubt about it. But you cannot say that, okay, I did a great job there, And now the application which is supposed to work and service that UI, if that's not designed well, then things are not going to work. So if you want to get into the whole leadership position of software engineering, software development, then you'll have to understand these things. And that's why this class, okay? So I just want to finish it. I know that one of the videos did not work good. Now, if you're interested more into, okay, you've explained to me what this domain modeling and domain-driven design is, I want to go down further down into actual software development. How does this translate into real software? I can make classes for that, but I think it's common sense. Once you know these things, you can get down to that level. But if you don't know these concepts, then you cannot get down to this level, right? And I'll tell you, over time, once you start thinking like this and making your thought process like this, then what happens is that sometimes the clients are talking to me, the business people are talking to me. I'm already in my head building a model, and I'm already in my head. I've decided how I need to build these systems. Sometimes people ask, "Oh, you're very smart." No, I'm not smart. I have the same amount of brain like you, but it's just that I've trained myself to divide my problems the way that you are talking to me, right? So that I can come down to the world and say that to my world, which is the software engineers world, and say that, hey, this is how we got to build it, and I feel like this will stay the test of time. Right now, test of time is a very big question mark, because every software we build is going to be thrown away at some point in time, but at least it's maintainable, at least it's understandable, so we can build and maintain our systems much better, and the customer is not affected because we made a bad design. Okay, so anyway, this is a good topic. So if you have any questions, let me know, but I'm going to end it here, and then we will go down to the real biz goal is actually take some data and put that into our Power BI. Okay, thank you.